The reflective properties of LT9779b surpass those found on Earth and Venus, which reflect merely 30% and 75% of sunlight, respectively. Consequently, LTT9779b is distinguished as the most reflective exoplanet known to date. Furthermore, LTT9779b's atmosphere is characterized by metallic clouds that emerge under extreme thermal conditions, which has taken researchers by surprise, given their prior expectations of a barren, lifeless entity. These metallic clouds likely perform a crucial role in regulating the planet's temperature. The discovery of LTT9779b is particularly significant as it embodies a rare type of planet, prompting astronomers to actively pursue further investigations into other ultra-hot Neptunes. The survival of this planet in proximity to its host star raises critical inquiries about the dynamics of planetary atmospheres. In examining the early solar system, its chaotic nature is believed to have facilitated the drift of planet-sized bodies into the Oort cloud. This migration likely occurred approximately 4.5 billion years ago, during the formative stages of our solar system. Moreover, researchers have theorized a mere 0.5% chance of rogue planets forming within the solar system. They further propose that a Neptune-like planet may have been captured by the Sun's gravitational influence. In the pursuit of extraterrestrial life, scientists identify exoplanets situated within habitable zones capable of sustaining liquid water. Notably, a total of 24 superhabitable planets have been cataloged as potentially more conducive to life than Earth itself. In a related effort, scientists from the University of Central Lancashire undertook simulations to analyze the formation of infant planets within dense gaseous disks surrounding nascent stars. Their findings reveal unexpected morphological developments during the planet formation process. The research delineates a bifurcation in theories regarding planet formation, gradual core accretion versus a more rapid instability mechanism. The latter may elucidate the rapid development of large planets situated at considerable distances from their stellar hosts. The advent of advanced telescopes, such as the Atacama Large Millimeter Array, ALMA, and the Very Large Telescope, has facilitated observations of young planets. These sophisticated instruments may yield additional evidence supporting the Smarties theory concerning the shapes of planetary bodies. Transitioning to the biological implications, animals would likely encounter significant adaptation challenges, as their life cycles are intricately synchronized with the lunar and solar cycles. This synchronization profoundly impacts their migration, hunting, and breeding behaviors. The gravitational influences exerted on oceanic tides would result in unpredictable fluctuations in ocean levels, thereby rendering the development of coastal cities virtually unfeasible and instigating chaotic environmental conditions. Consequently, human history would experience dramatic alterations, as populations would be unable to traverse oceans, culminating in disparate developmental trajectories across various continents and a potential absence of mass extinction events. One particular exoplanet, located a mere 90 light-years from Earth, possesses an atmosphere rich in water clouds and maintains a temperature akin to that of our planet. Its orbit around a dim red dwarf star designates it as a compelling candidate for further study. Additionally, the discovery of M51ULS1, a planet situated beyond the confines of our Milky Way galaxy, underscores the potential for detecting life in remote regions of the universe. This finding raises challenging questions regarding existing beliefs about planetary formation. Super Saturn, a gas giant adorned with an extraordinary ring system, poses significant inquiries about the processes involved in the formation of both planets and their circumplanetary rings. Its size and mass far exceed those of Jupiter, rendering it a noteworthy discovery. Another intriguing planet exhibits a massive cloud and an elongated tail reminiscent of a comet, harboring wealth surpassing the cumulative riches of Earth. The extreme environmental conditions on this planet facilitate the formation of diamonds. HAT-P7b is recognized for its potential gem-enriched clouds that may yield rains of rubies and sapphires, despite its location approximately 1,000 light-years from our planet. Due to its proximity to its host star, the temperatures experienced are extraordinarily high. Kepler 438b, an Earth-like exoplanet residing within the habitable zone, is posited as a potential sanctuary for life and a prospective new home for humanity. However, interstellar travel to this destination would necessitate an impractical duration of 470 years. The surface of this planet is dominated by molten magma, establishing a hostile environment where the presence of breathable oxygen is unattainable. Researchers continue to investigate K2 to better comprehend its distinctive characteristics. In contrast to Earth, K2 is characterized by tidal locking, resulting in one hemisphere perpetually exposed to sunlight and extreme heat, while the opposite side remains enshrouded in uninterrupted darkness and frigid temperatures. The extreme circumstances on K2 include winds that can reach velocities of 3,000 miles per hour, thereby establishing it as one of the most inhospitable environments known to humankind, far surpassing any storms documented on Earth. Pluto's distinct cryovolcanoes present a stark contrast to the volcanic activity observed on Earth, as these structures erupt ice instead of lava, a phenomenon driven by extreme pressure and low temperatures. This captivating occurrence illustrates the geological diversity within our solar system. Venus, frequently referred to as Earth's twin, exhibits extreme weather phenomena, including sweltering temperatures and clouds laden with sulfuric acid, rendering it a profoundly inhospitable environment for life as we recognize it. Its retrograde rotation and unique atmospheric characteristics further enhance its distinction. Uranus is notable within our solar system due to its extreme axial tilt, which induces peculiar seasonal fluctuations and a distinctive rotational behavior. This peculiar tilt is hypothesized to have arisen from a collision with a massive celestial body in the past. The existence of zombie stars, such as LP40365, poses significant implications for our understanding of stellar evolution and the processes governing supernovae. The existence of such stellar remnants necessitates further investigation into astrophysical phenomena. The unique attributes exhibited by LP40365 illustrate that not all stars conform to the established life cycle, thus emphasizing the intricate nature of astrophysical events and their various outcomes. The presence of zombie stars also incites inquiries regarding the nature of dark matter and energy within the cosmos, suggesting that there remains an extensive frontier to explore beyond the realms of visible matter. The internal structure of Earth is composed of iron and nickel, with a solid inner core and a liquid outer core. This stratification significantly influences the planet's geological properties and magnetic field. Moreover, Mars is home to Olympus Mons, the largest volcano in the solar system, which rises 16 miles into the Martian atmosphere. The existence of this colossal volcano reflects the planet's geological history and prior volcanic activity. It is noteworthy that gravity on Earth exhibits slight variations depending on one's geographical location, influencing weight by approximately 0.5%. Such differences can be distinctly observed when comparing weights measured at the equator versus those taken at the poles. The James Webb Space Telescope has made groundbreaking discoveries pertaining to ancient dwarf galaxies that contributed significantly to the reionization process, emitting powerful radiation. These galaxies played a pivotal role in dissipating the primordial hydrogen fog that enveloped the early universe. Gravitational lensing represents a methodological approach employed by astronomers to investigate distant galaxies. This technique enables scientists to observe faint galaxies and elucidate their significance within the evolutionary narrative of the universe. Supernovae originating from massive stars are responsible for the creation of heavy elements and black holes, profoundly influencing the cosmos. These explosive events have played a crucial role in both the reionization of the universe and the genesis of new stars and galaxies. The existence of a molten layer beneath the moon's surface may account for moonquakes, insinuating that tectonic activity on the moon may be more intricate than previously acknowledged. This revelation has the potential to reshape contemporary understandings of lunar geological processes. The implications stemming from this discovery extend beyond lunar confines, positing that analogous concealed structures could exist on other celestial bodies. This could further enhance our understanding of planetary geology throughout the solar system. Lunar lava tubes, which formed as a result of ancient volcanic activity, may serve as viable shelters for future human colonization efforts. These natural structures could offer refuge from the harsh conditions present on the lunar surface and may even contain essential water resources. The concept of potential recycling in the universe raises compelling questions regarding its historical and future cycles, thereby hinting at a more profound understanding of cosmic evolution. This notion challenges conventional perspectives on the linear progression of time. A notable variant of this theoretical framework is shockwave cosmology, which posits that the Big Bang emanated from an explosion of a black hole, giving rise to our ever-expanding universe. This hypothesis provides a unique lens through which to view cosmic origins. Despite the allure of these theories, a lack of experimental evidence exists to either substantiate or discredit them, rendering them largely speculative. This uncertainty fosters ongoing curiosity and a desire for exploration within the field of cosmology. Curiosity, the Mars rover, has identified seasonal fluctuations in oxygen levels on Mars, indicating dynamic changes within the planet's atmosphere. These variations point to complex environmental processes that continue to be the subject of active investigation. The detection of methane on Mars raises pertinent questions regarding its origins, with hypotheses suggesting both biological and geological contributions. This gas is critical as it may suggest the presence of past or even extant life. Recent discoveries indicate that ancient deluges may have sculpted the Martian landscape, giving rise to substantial channels indicative of water flow. This evidence supports the hypothesis that Mars was once significantly more habitable than currently believed. Active galactic nuclei, AGN, represent energetic regions located at the centers of galaxies, emitting immense amounts of energy. Their brightness often exceeds that of surrounding stars, thereby significantly influencing adjacent cosmic structures. Quasars are recognized as the most luminous subclass of AGN, powered by supermassive black holes, allowing them to outshine entire galaxies and be observable from billions of light years away. The identification of Gaia BH3, a massive stellar black hole, exemplifies the diverse array of black holes present in the cosmos. Its relative proximity challenges previously held assumptions regarding the distribution of black holes in the universe.